Hello again. I'm picking up where I left off in the last video. We had this algorithm. We were going to do a round trip from home to next, to next, to next, to next, to next, to next, back to home. And I wanted to compute how far I went, the distance, using the taxi cab metric. So what I'm going to do is I'm going to say while something. So perhaps that's going to be while the next place I'm at is not home, let's say, for a minute. What I'm going to do is I'm going to compute the distance between my current and my next. So if current x minus next x is less than or equal to 0, well, it can't be negative, so absolute x should equal minus that. Else, well, it's already positive, so I just have to let absolute x equal current x minus next x. Now I have to do the same thing for y. So if current y minus next y is less than or equal to 0, same thing, absolute y equals minus current y minus next y, else absolute y equals current y minus next y. Well, now I have the two numbers, so I can add. So distance equals the distance I've had plus the difference in the x's plus the difference in the y's. And now I have it. Now I have to get ready for the next one. Well, I just moved. I'm no longer where I was. I moved to next. So current x equals next x, and current y equals next y. And now I'm going to read in the next place I want to go. So I'm taking that and I'm reading it in. I'd like to, when I get out of here, I'm going to print out the distance. Distance is, and then I'm going to have dist and the indel, and then the return 0. Now, this program is not going to work. There's going to be an error in it because we forgot something in the algorithm. But before I do that, I have to figure out what the while is. Well, when do I end? I end when I'm back home. So it would be nice to just be able to say that current equals home, but I can't because that's where I started. So that's not going to work. So what if I say this? I want to stop if the next place I'm going to go to is home. Now that's when I want to stop. A nice little trick is to say, I want to go when that's not true. So what that is really saying is, while it is not true that next is home, keep going. That's going to be part of the problem, though, and you'll see why in a minute. So let's see if I made any typos. Doesn't look like I did. So I'm going to start at 310. And I'm going to go to 312. That distance should be 2. Pardon me. I wanted to print out something. I wanted to show you the distance as it was going along. So I want to print right here. See out distance in L. This gives me a shot to see how it's going as I do it. So 3 and 10, 3 and 12. Distance should be 2. It is. 6 and 8. The difference in the x's is 3. Difference in the y's is 4. 3 plus 4 is 7, plus 2, 9. Let's see now. Let's go 5 and 1. Excuse me. Alan, can you call me back in about a half hour, please? Thank you. Okay, so pardon me for that interruption. So 5 and 1. The difference in the x's is 1. The difference in the y's is 7. 1 plus 7 is 8, plus the 9, 17. Now I'm going home, and now you're going to see the error. It's still 17. That's because I never computed the distance from the last place to home. So right down here, I basically have to go up and do this part all over again. Right down to here. Control C. Put that in here. And what I'm saying is, my current is where I was last. Now my next is home. And now I'm going to compute that as the last distance I compute. So in the algorithm now, I have to add back here, compute home last leg distance. And I better put that back here. Let's see somewhere. Compute distance from, this is not in the loop. This is done outside the loop. From next to home. Oh, pardon me. From current to home. And home is same as next. So let's see if that makes it work now. So now I'm going to run the program. And I'm going to say 3 and 10. And we'll go 5 and 6. So 4 and 2 is 6. And we'll go 12 and 1. That's 5 and 7 is 12 plus 6, 18. And I'll go home now. 3 and 10. And the distance is still 18. And I know why. I forgot to add it in. See down here? After this, I was supposed to say dist equals dist plus absolute x plus absolute y. I didn't copy that. I was supposed to. Now I think we get it right this time. Let's hope. 310. 6, 5. 7 plus 3 is 10. 3 plus 5 is 8. 9, 2. That's 4 plus 3 is 7 plus 8 is 3 plus 3 is 6 plus 8 is 14. And let's go home. 310. That will be another 6 plus 8, which is 14 plus 14. Distance is 28. So the program works. Now, all those little mistakes are made. That happens. Sometimes you don't think of something, and you have to test the program. If it doesn't work, you have to figure out what you did wrong. And that's just the way it is. So what do I want you to really get from this? Well, I kind of hope that you're getting a better feeling for whiles and booleans and things like that. It's got to be done. You've got to get that down. Also, I would hope that you might see in your homework a use for something like this. It might be something you can do in one of the homeworks. I'm not telling you which one. But that's a nice trick. What it really says is, while I'm not home, while next does not equal home, because I know I want to stop when next equals home. So that's it for now. I hope that everything's fine. I will copy this program into that handout that I'm going to put out on the web. And again, you have to look at the first one of these that I'm going to be posting before to understand this one. Because the two go together, I just couldn't put them together since I had an interruption between them. So I will be putting it out, and you'll get a notification.